camera. We are now recording. Let's get the slideshow set up from the current slide. And here we go. All right. It seems like to me we did this slide, didn't we? That's where my mark is. Had we done this one yet? Y'all are kind, aren't you? Okay. Tyrell is here. Anyone else walked in since I called roll? Okay. Whoops. This isn't mine. Okay. 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 All right. Just like with numbers, we can do these operations with functions. We can add them, subtract them, multiply them, and divide them. Here's the key. F and G are both functions. Functions have these characteristics about them, you know, as in domains, ranges, that kind of stuff. Okay. If F and G are these two functions, they've got to have overlapping domains. Okay, what do we mean by that? I don't know if y'all are familiar with Venn diagrams, but if this block is all real numbers, and this circle right here would be the domain of F, but the domain of G would be here, then it's only the values here where the domains overlap can you do any of these things with it. Now, if F and G both have domains of all real numbers, no sweat. They overlap everywhere. But if they don't, then you have to restrict yourself to just that portion where they do have everything in common. Then, once they are in that, for all x's common to both domains, that's what we mean, overlapping domains, common to both domains, the sum, the difference, the product, and the quotient of F and G are defined as follows. Okay? If you're adding two functions, F and G, the sum function is basically F of G, F of X with G of X. Just what you would expect, I hope. The difference function, F minus G of X, is F of X minus G of X. The product function, Fg of X, is F of X times G of X. And I think I recognize this guy. I've seen him somewhere before. Jonathan's here. Okay. Well, somehow there you are. Thought I had already marked you that. Okay. It's F of X times G of X. And then finally, the quotient function. This is the one to watch out for, folks. F divided by G of X is merely F of X divided by G of X, except, big caveat here, now you have to exclude, remember, F and G have their own domains, but now you have to also exclude from G, even though it's in its domain, any values X that make G go to 0, because you can't divide by 0. So not only do you have the domain of G, now you have to restrict it, so the range of G is not 0 also. Okay, so you have to restrict those as well. Okay, does that make sense? Let's do example 1 and see how much sense it makes. Okay? Given that f of x is 2x plus 1, and g of x is x squared plus 2x minus 1, find f plus g of x. How do you find f plus g of x? What's the definition of that? F of x plus g of x. Okay. Now, just so we don't worry about any, f of x is a polynomial, linear polynomial function. What's its domain? All real numbers. G of x is a quadratic polynomial function. What's its domain? All real numbers. No sweat with the domains. Everything's in both domains, so this should work. Okay? So f of x plus g of x would be what? What is f of x? 2x plus 1 plus, what's g of x? X squared plus 2x minus 1. Okay? Now, I didn't really need the parentheses in there. Okay? But I put them there so you can see this is f, that's g, with the plus in between. This is your f plus, this is your g. Okay? Now, because I really didn't need them, they don't really contribute anything at this stage, what I'm going to do is erase those. Okay? I put them in there just so you could see those are f plus g, but I erase them so you help you see what to do. What would you do? Combine like terms, and what do you get? X squared plus 4x. Done. Okay? That's your sum function. Okay. So we've done the first part from f plus g of x. There it is. Okay? Then evaluate that sum when x is equal to 3. So this is f plus g of x. That's what that is. Okay? So we want to do f plus g at 3. And what would you do there? Plug it in, plug it in. What would that give you? 3 squared plus 4 times 3. And that would be 9 plus 12 is 21. Got it. Legal in most states. Okay. Does that make sense? All right. Good deal. Let's see how they do it. Let me erase all the ink. Any questions on it? Okay. Now, maybe I didn't say it at the beginning. I usually do. Did y'all have any questions before we began? I think I got rushed through it. Were there any questions? It came up earlier. Before. Anything before we get started on this even though we've started. No questions? Okay. Want to make sure. Let's see how they do the problem. So they rewrite the problem. F plus g of x is f of x with g of x, which is exactly what we had. And they do put the parentheses in there so you can see. In fact, they put them in pink or red or something so you can see. That's f, that's g. You're adding them together. So that means you just combine like terms, and they did it like that. Okay. Same thing we got. Okay. Now that's f plus g of x. F plus g of 3 would be 3 squared plus 4 times 3. And that would be 21. Good deal. Any questions? All right. They're skipping example 2, example 3, example 4. Yeah, so let's go back and get as many of those as we can. Now, also I want to say this. I said it before, I'll say it repeatedly. After every example in the book, you find a checkpoint. So when you get home, working on quiz or something like that, you know, if you're having trouble with some of that, go back and check, do your checkpoints, yeah. You certainly could. That's a very good question. You certainly could do that. We had f plus g of x was x squared plus 4x, right? If you wanted to, you could factor an x out and leave you what? X plus 4. That's perfectly fine. Not required, but certainly doable. Okay? Let's now, in that form, figure out what f plus g of 3 would be. What would that be? 3 times 3 plus 4. That would be 3 times 7, which is 21. Same thing we got. So either way works. Okay? If the problem specifically said, simplify your answers, probably I would have gone on and done the next step. But they didn't specify. They were happy with x squared plus 4x. I'm happy with it. Now, this jumps a different rabbit here. But when you're doing these computerized management packages like WebAssign and those others, those things, computers really are dumb. They only do what you tell them to do. They are looking for one answer and only one answer. You are absolutely right. That is a perfectly correct answer. That's a perfectly correct answer. Guess what? Those computerized programs only recognize one, okay? So they'll tell you the other one's wrong when it really isn't. And that's one reason I get so frustrated with them, because sometimes the student will simplify a result and they'll tell them it's wrong. And it's not wrong. So basically, rather than having to say, no, you're okay, you're all right, it's fine, I just finally quit using them. Now, if they get them good enough so they recognize all answers, I may go back to using them, but that's going to be really, really, really hard to do. But I'll get off that soapbox now. But yeah, you're right. You could simplify the answer by factoring. Okay. So let's clear that. Good question. And let's do example 2. Okay. Given that f of x is equal to 2x plus 1, and g of x is the same thing, find sometimes it takes and sometimes it doesn't. The problem is exactly the same, but now we're asked to find f minus g of x. Okay? Then evaluate it when x is equal to 2. So we'll do that. Let's do f minus g of x. What is f minus g of x? F of x minus g of x. And again, domains are no issue. All real numbers everywhere, no sweat. So what do we do here? Plug them in, plug them in. Again, I'm going to put parentheses here. 2x plus 1 minus x squared plus 2x minus 1. Now, actually, this first set of parentheses really does nothing for you. They're just there. Okay? The second set here, though, you can't just throw away. And don't even try, because they are preceded by minus sign. If a set of parentheses is preceded by anything, then use it. Distribute before you throw it away, remove the parentheses. Okay? So that's our next step. Let's get rid of erasing mode. Okay. And that would be 2x plus 1 minus x squared minus 2x plus 1. Excellent. Don't let those signs sneak up there and bite you somewhere, okay, because they will. Okay. What do we get now? Negative x squared plus 2. Excellent. And that's your f minus g of x. Okay? They're asking for it, though, when x is equal to 2. So what's f minus g of 2? Negative 2 squared plus 2. And that would be negative 4 plus 2 equal negative 2. And that's what they got. Good for them. Couple things to note. Y'all did it right. This is a negation sign. That's the exponential sign. If you remember, please excuse my dear Aunt Sally or whatever it is, you do the exponents before you subtract or negate. So always square before you do this. Now, if that had been a negative x squared negative x in parentheses squared, then that would have been a positive x squared, because you do what's in parentheses before you square. Okay? So, y'all did it right. Now, I meant to do this on the last one. I forgot to. We had other questions. What would have happened if we had plugged in our 2 there rather than down here? What would we get? What's f of 2 up here. 4 plus 1 is 5. And what's g of 2? A little louder. 4 plus, wait, it's g of 2. Plus 4 minus 1, and that would be 7. And what's 5 minus 7? Negative 2. So it doesn't matter which order you do. You can plug and chug or chug and plug. Either way. Whichever works out easier to do. Find what the difference function is first, then plug it in, or plug in, find what it is, and then take the difference. It works both ways. They ask you, though, to do it this way, so you did. Good deal. Any questions on that? Okay. If not, let's erase all this. Everybody got it? Everybody okay? Then let's do, I'm guessing a product function, example 3. If f of x is equal to x squared, new functions here, and g of x is equal to x minus 3, find fg of x. And what is that defined to be? F of x times g of x. And that would be x squared times x minus 3. And what would that be? X cubed minus 3x squared. Now, on this one, I think I'd leave it like this. Because factor it out and get back to this. Both of them are good forms, but that's what they gave you. It really doesn't matter. But I wouldn't do extra work to get back to just where I came from. But you can. It's perfectly good answers. Now, does this have another part? Yes. Then evaluate the product when x equals 4. So this is f g of x. What's f g of 4? All right. Here comes the Jones sisters. Okay. Alexis and Allison. Good deal. Getting to be a good attending class. Started out this morning, I think, what, 6? But it's grown. Good. Okay. What would f g of 4 be? 4 cubed minus 3, 4 squared. Okay? Yeah. And 4 cubed is 64 minus 3 times 16. That would be 64 minus 48 equal 16. Okay. How'd the book do? Good for them. They got it right. Now remember, each one of these has a checkpoint. I was starting to harp on this before. Those checkpoints, remember, they have audio, video solutions at larsonprecalculus.com. So that's why I say take advantage of them, especially if it's something you're not quite sure how they're doing. Get it. You'll hear them talk about it. Maybe they'll say something that breaks the ice for you or enlightens you or say, oh, that's what they meant. So give them a shot. Okay? And then let's go to, anyone need this up any longer? That's example 3. Let's go to example 4. Okay. This one has us doing 4 things, okay? First, we're finding, let's see, write down the functions first. F of x equal the square root of x, okay? G of x equal the square root of 4 minus x squared, okay? And then find the domains for, no, then you find f divided by g of x, g divided by f of x, and then the domains of f divided by g of x and g divided by f of x. All right, 4 things to do here, okay? Now, I'm not going to wait till the end to do them. I'm going to start right where I think you should at the beginning. Like the others we said, not all of them, but we thought it, didn't we? What's the domain? What's the domain? All the others were polynomials, all real numbers. These, however, are not polynomials. So what's the domain of f? Okay, x greater than or equal to 0. Very good. How about g? What's the domain of it? Okay, let's start one step at a time. What's true? What has to be true? What's inside under the radical, 4 minus x squared, has to be what? Greater than or equal to 0. It has to be positive. It can't be negative. So it's greater than or equal to 0. Now we got a little problem, don't we? That's a quadratic. You can start plugging in values and see if you can guess what those would be. Or you can do it a little more algebraically, which may not be very fun either. And here's Justin. All right, we're just missing Embry. Has she come in yet? Anna? Anthony and Shay, Yolanda and Ashley. Okay. Top part of the alphabet doing quite well. Middle part doing pretty well. Bottom part falling apart. Never mind. Okay. So what could we do here? What do you notice about this expression? Say again? Is a difference of 2 perfect squared. And what could you do with that? Factor it as. Okay, let's do 2 plus x times 2 minus x. Okay, not that it's going to matter that much, but just keep it in that. That has to be greater than or equal to 0. Okay, now we put on, of course, we keep our thinking hats on, don't we? Okay, we have a product of 2 entities that's greater than 0. It has to be non-negative. What? That will work, or if both factors were negative, the product would still be greater than or equal to 0, wouldn't it? So we have 2 conditions we have to consider. You said the first one, so we're going to set both of them. This implies that either, it's writing up here, either 2 plus x has to be greater than or equal to 0 and 2 minus x greater than or equal to 0, or 2 plus x has to be less than or equal to 0 and 2 minus x less than or equal to 0. So we got all this to consider. Let's do that first one first. They're not hard, they're just a little tedious. What would you do? Subtract 2 from both sides of the inequality. That doesn't change the sign any, and that gives us x greater than or equal to negative 2. All right, I'm going to come down here and draw me a number line. Okay? Here's my 0, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7, 8. This is our number line for x. So this says x is greater than or equal to negative 2. There's negative 2. Since the equal sign's there, I can count it, and this will do everything to the right of it, right? Okay. And, though you have to be restricted here, what do we get here? A little louder, I can't make it out. Okay, you're going to add x to both sides, is that what you said? Okay. Add x to both sides, that's one way to do it. And that gives you 2 is greater than or equal to x. Okay? We'll find our 2. Here it is, the equal sign there. But the 2 is greater than or equal to x, so that means x is on the lower side. So that's everything this way, right? But it has to be both, and. So that means we start here and end there. So there's one possible domain for this function here. -2 less than or equal to x less than or equal to 2. That's one possible domain. Okay, let's do the next one. I'm going to erase what we just did because I've written down my answer here. I'm going to leave those in place for a certain reason. Okay, the other possibility was that this one down here. 2 plus x less than or equal to 0. What would you do first? Subtract 2 from both sides, and that gives you x is less than or equal to -2. Well, there's my -2 equal to x is less than that would be all values downhill from there, right? Okay, let's do the next one. 2 minus x is less than or equal to 0. Going to do the same thing you did before. Add x to both sides. We can do that. And that gives you 2 is less than or equal to x, meaning here's your 2, but the x's are 2's less than x, so meaning all the x's are over here. Can that and that possibly be true? All numbers that fill in here and in there. There aren't any, okay, because that's an and up there. Both have to be true. So this doesn't give you. So this, by the way, is your domain of this function. Here's your domain of that function. Okay? So we've done that part. Now, let's do f divided by g. What you reckon that is? F divided, well, I've already written it, but let's start write it again. What does f divided by g mean? Okay, that means f of x divided by g of x. And basically, what would that be? The square root of x divided by the square root of 4 minus x squared. That's it. You just write it down. I can't think of a thing you could do to simplify that. No, they didn't say to in this one. They are going to say give the domain. That's over here. You want to go and do that? Okay. So let's go back and let's use our number line here. Okay, but I'm going to erase that part because we didn't use that at all anyway. So let's do, since I've used dark blue for my g function, let's do what color you want for the L function. Give me a color. Pick a color. Blue. Light or medium? Second? Yeah, there's my baby blue here. Okay, there she is. Okay. Now, how do I express Sx greater than or equal to 0? How do I express that? That domain here. Okay, you start with 0, and it's included because of the equal sign. And then which way do we go? To the right. Okay? And then we already did this one, so I'm going to go back to dark blue here. And this was everything between -2 and 2. So it's only the stuff in here. So what's common for those? 0 to 2. You got it. So the domain of, okay, the things common to those two are 0 to 2. Okay? But the domain of this has one other restriction on it. What is it? That this thing cannot be 0. What would make that 0? Yes, +2 or -2 would make that 0. Perfectly fine here, because you could have 0 here, but you can't have 0 down here. So what you would do then is all you would have to do here is to change this bracket and that mess there to an open circle and make that a parentheses. So the domain of this is 0 is less than or equal. You can have the equal sign, no problem there, x, and x is less than 2. You can't have equal to 2 because that would make the denominator 0. So that's the only thing you change from that. You have to eliminate all values that make that 0. This minus 2 would have made it a 0 too, but that was already excluded from the domain of both because your first one had to be greater than or equal to 0. So that was already a miss for you. Okay. Now let's flip it the other way. G divided by F. What you reckon that is? What's that by definition? G of X over F of X. And what would that be? The square root of 4 minus X squared over the square root of X. Now, I was a little surprised no one said this, but I was glad they didn't. But sometimes we don't like dividing by radicals, either that time or this time. The book's not carrying now, so I wouldn't mess with it. You could fiddle with that if you wanted to, but I don't think it makes anything any clearer. That's a perfectly legitimate answer. Okay? Now, what do we do with this domain? Again, you had to have what's common between the two, so this gets thrown away when you're doing any of these functions. If you had been adding these or subtracting these or multiplying these, you'd have to limit yourself to the parts that are common. So we're limited here, but what's the difference here? Yes, the 0 has to be excluded. The 2 is now perfectly fine. So what we do here is color back in the 2 here, but take out the 0 here, because you have to exclude all the values that make your denominator 0. And I took out my tick mark too. Okay, so now it's this. So that opens the parentheses here and closes with a bracket there. So this is open parentheses 0 to 2 bracket. Okay, I did interval notation here. I did shorthand notation there. Either way, I don't care. Okay, does that make sense? It's a little more complicated than the others. Number one, the domains of everything wasn't all real numbers, so you had to do that. But then two, this was dividing, so every time you divide, here you have to ignore all values that are legitimate in this domain, but can't be in this one because it's in the denominator. This time, everything that was legitimate here is included, except what makes the denominator 0, so you have to exclude it. Make sense? All right. Again, there's a checkpoint. Well worth your time, especially if this is a little fuzzy to you. Go home, do the checkpoint. If you can't get it, then check your LarsonPrecalculus.com, because you don't know if you got the right answer anyway, so that's the only place to check it. All right, any questions about adding, subtracting, multiplying, or dividing functions? Making sense? No eye contact. Okay, never mind. Okay. Say again? Except all that. Okay. That's everything making sense except all that. Okay. No, this at the end? Yeah. Okay. Do you see why you have to restrict domains? Only 2 times you restrict domains that we've hit so far. Anytime you have a variable in a denominator, you have it here and here. You can't let that denominator be 0. Okay? The other time you have to restrict domain is anytime you have a variable inside a square root, which we have in both of those in everything. So we have to restrict the domains there. And since we're dealing with these two functions, you have to limit yourself to what's common between the domains. Here's the domain of F, here's the domain of G, so you have to restrict yourself to what's common between the two. But then when you divide, you have to exclude what has to be excluded to keep the denominator from being 0 here, or here, exclude that. It's just the process of keeping up with what makes those denominators 0, or what makes those radicals, the radicand, negative. You have to throw those out. Okay? Try those. They'll talk you through those as well. Okay. Any questions? Okay. All right. Now we're moving to the composition of functions. I was hoping, I think I'm probably true on this, that the adding, subtracting, multiplying, dividing, not that bad. They sort of make sense. We've done things like them before with real numbers. But have we done anything like these, composition of functions? Another way that combining two functions is to form a composition of one with the other. Here's the example. If f of x is x squared, perfectly good function. G of x is x plus 1, another perfectly good function. The composition of f with g, the order matters here, of f with g, is f of g of x. Okay? What do we mean by that? F composed with g, that means what you're going to operate with f is actually the g function. So the g function is this thing, you put that in here, and then the f function says to do what? To everything that's inside here, you square it. So that would be x plus 1 squared. You see what it's doing? We've done the individual steps before, now we're sort of combining. Does that make sense? Okay. The composition is denoted by F circle G, which to me sort of looks like fog. And that's sort of what I get when I look at your face. No, I'm not saying that. Okay. So F of G, or F composed with G, and it says F composed with G. You always do the outer one on the out and the second one on the inner. Plug in the inner first, then operate on the inner with the outer. Okay? And go from there. Okay? Want to try a few? Sure, oh no. Okay. Here's the definition of the composition of functions. Okay? Composition of function f with the function g is f composed with g of x is defined to be f of g of x. Now here's the other thing. Besides the fog thing, I think of this little o as odd. F of g of x. That's exactly what it is. F of g of x. That gets you in the right order, puts the right thing inside, and you always start with the middle and work your way out. Now, this always gets us as the domain. The domain of a composition of two functions is a set of all the x values in the domain of g, because that's what we're starting with is g. So they have to be in that g, but also so that the range of g of x, the things coming out of the function when you crank the handle, are in the domain of f. Okay? So you have to have both. The ones we looked at before, everything was all real numbers, so no sweat anywhere there. Others you might run into it, but most of the time they're pretty obvious. Now this is called a mapping illustration of a function. We're starting here with the domain of g, okay? Because that's the innermost function here. The domain of g is x. G operates on this x to give you g of x. That's now the range of g. But this is the domain of f. The range of g becomes the domain of f. So then we operate f on that, exactly like it shows here, and that gives us f of g of x, which is f operating composed with g of x. You're starting with the x, operating on it with g, then operating on the output of g with the f, that becomes the input of f, and that gives you f of g. Okay? This is sort of like, remember my sausage grinder? If we had done all that, ground it all with the sausage, that's maybe G operating on that, and then we put it on the blender to mix all the spices in, okay? That would be another function operating on the output of this, okay? I like food, so I think in terms of food. All right, now we get to do something. Here's our f of x, x plus 2, g of x, 4 minus x squared. Find the following. F of g of x. Tell me what that means. F composed with g of x. F of g of x. Very good. And what do we plug in first? Okay, you plug in the g, and that's 4 minus x squared. Okay. Now, what does the f function do? It takes whatever's in here and adds 2 to it. What's in here now? 4 minus x squared. So this will be 4 minus x squared plus 2. Simplify that and you get 6 minus x squared. Done. Okay? Now, we didn't worry anything about domains, did we? Because the domain of f is all real numbers. The domain of g is all real numbers. The output of g is not all real numbers. It's all numbers 4 and less. But who cares? All those will fit in F because F had the domain of all real numbers, so we're not sweating that at all. Okay? Now, let's do G composed with F. What would that mean? G of F of X. And what do we plug in first here? X plus 2. That's what f of x is. You just plug it in, plug it in. And then the g is going to operate on that. Well, what does that do? The g function starts with 4 and subtracts from it whatever's in here in the parentheses squared. What's in your parentheses? X plus 2 squared. Now we got a little more work to do on this one. That will be 4 minus, what's x plus 2 squared? X squared plus 4x plus 4. Very good. I take it he did the shorthand way. Square the first, twice the product, square the last. Okay? One more step. 4, maybe 2, minus x squared minus 4x minus 4. And now the plus and minus 4 add to 0. There's your answer. Minus x squared minus 4x. Which you could have factored out the minus x and say minus x times x plus 4. Be careful when you do that you get your signs right. Or you can leave it like that and not risk it. Now I've got a question for you. Any of you think that F composed with G is the same as G composed with F? No way. Generally, composition of two functions is not commutative. You can't go either way. It's going to be different. Except for some really special cases, which we're going to hit later. Okay? All those special cases, you know you got something special in your hand. All right. Any questions on that? The last one asks for G composed with F of 2. What in the world is that? What is G composed with F? That's what we just did here. So this would be negative, open parentheses, negative 2 squared minus 4 times negative 2. Bunches of negatives in there. Let's be careful with them. Okay, how do we begin here? Minus that negation sign, 4 plus 8, that's equal to positive 4. Very good. All right. Now, do want us to try something else, and you don't have to, but I'm just saying just to see. How is this defined? G of f of minus 2, right? So if you go up here and do f of minus 2, what would that be? Negative 2 plus 2 equal 0. Okay, so now what we got here is g of 0. Well, let's go here and do a g of 0. What does that give you? 4 minus 0 squared, which is 4. And isn't that what we got here? Yes. Okay, so again, if they told us to do this and do that, once we had done that, it's easy to just plug in. But if they hadn't told us to go through that, and this is all they were looking for, you could have either gone this way and got plugged in, or you could have plugged in and then done your composition here. You've already paid your money, you get to take your choice. Okay? So either way works. Make sense? Good deal. All right. Now, like I said before, let's see how they do them. Okay. So they rewrote f composed with g of x, and they identified just like you did as f of g of x. You plug in what the g of x is, which is 4 minus x squared. Then you operate it on the f, which says take what's in there, 4 minus x squared, and add 2 to it. And when you do that, you get, they rearranged it, made it minus x squared plus 6. Fine. 6 minus x squared would be just as fine. Unless you're doing a computerized homework exercise, and then one of them would be right, and they say the other one's wrong, and it wouldn't be wrong. It would be perfectly fine. Okay? Then let's do the B one. This time, g composed with f. It's g of f of x, so you put the f of x in first. That's x plus 2. And then the g says start with the number 4, and then subtract what's in parentheses square. Because it was 4 minus x squared, so now it's x plus 2, so 4 minus x plus 2 squared. Now you've got to square your x plus 2, just like y'all did. X squared plus 4x plus 4. Then negate what's in parentheses, and skip a few lines, and you get minus x squared minus 4x. And note that in this case, and let me say this, in most cases, f composed with g of x is not going to equal f composed, g composed with f of x. In most cases, that's going to be an inequality there. In the few cases they are true, special cases, pay attention to them. They're going to tell you something else. Okay? So, let's finally do the last part. F composed of g of minus 2 would then be to take our result from before, just like we did, minus a negative 2 squared, minus 4 times a negative 2, substituting in, it'd be a minus 4 plus 8 is 4. And then I showed you the other way you could check that and get what 4, that you get 4. Okay. That was example 5, and they're skipping example 6. So let's go back and do example 6 here. Okay. Find the domain of f composed with g of x for the functions f of x is equal to x squared minus 9, and g of x is equal to the square root of 9 minus x squared. Okay. And all it says is find the domain of that. We're looking for the domain of this. The domain of that with the functions defined like this. So where are we going to begin? No, go ahead. Yeah, with g of x. Because where you begin, this is f of g of x. So you can start with g of x. You have to figure out what the domain of g is. Because that's what you're starting with. And what is that? Ooh, they had to pick the messy one, didn't they? But let's think about this. I mean, we had one very similar earlier. Yes, everything between 3 and negative 3. Now, earlier, and this is tying all of this together, folks, if you just took this part in here, okay, and pictured that as a graph. This book loves doing that, right? How would that look? Okay. Say again? Yeah, negative 3 to positive 3. You're absolutely right. Think of how that looks. Our parent functions is your x squared function, right? But we're negating that, so it moves it down here. And then we're adding 9 to it. Okay, so that brings it up to here, and then it goes down here and down here. It's from somewhere here to somewhere there. That's the only places where this thing is greater than or equal to 0. So you can think of it that way too, and minus 3 to 3 is going to be exactly. You don't have to do this, but I'm just saying all this stuff ties together, folks. It all makes sense. It's consistent. So yeah, our domain here is minus 3 is less than or equal to x is less than or equal to 3. How do I write that in interval notation? Bracket, negative 3, comma, 3, close bracket. Got it. Okay. So that's where we began. Okay. Now the output of this, when you do g of x, is going to be all positive numbers. Well, no, positive numbers up to 9. Okay, 0 to 9. Well, you can feed that into F, no sweat, because F, where is it? Right here, is all real numbers. So those numbers go in, so that is your domain for the whole thing. Minus 3 to 3. Okay. And that's all they were looking for. And there is a checkpoint there, so take advantage of it. And do it. Okay? All right. In these two examples, you form the composition of two given functions. In calculus, which is this pre-calculus leading up to, it is important to be able to identify two functions that make up a given composition function. For instance, if this is the function you had, h of x is equal to 3x minus 5 cubed. Do you see that as a composite function? Isn't it this thing being operated on by that? So this would be your g of x, and x cubed would be your f of x. So you see you're operating on a function with a function. That's what it means to compose two functions. So your outermost function would be the outermost thing here, the cubic function. The innermost function would be the thing that's innermost here, 3x plus 5. So h of x would be 3x minus 5 cubed, which would be g of x, 3x minus 5 cubed, which would be, in the cubic function, is this f function, f of g of x. Okay? So basically what we're doing is decomposing a composite function. You look for the inner function and the outer function. And literally that's what it looks like. The inner function h, this was the inner function, so make that your g, and then the cube was on the outside, so make that your outer. Okay? That's what you do. Say that again? Do another one? Okay. Yeah, there is an example in the book, example 7. I just don't know if we have time. Do you want to take time to do it? Or do you want to hear a dumb story? Huh? What's that? Okay, we can start with it next time, and that refreshes us. You want to do it now? Huh? Which you want to do it now? Okay. All right, so you want a dumb story. Okay, let's do a dumb story. Okay, we'll pick up then. Let me first give you homework exercises. I don't want you to leave home without those. And we came close to finishing the thing. Do number 3. Do any of the odds 5 through 11. Do any of the odds 13 through 23. Do 25. Do either 27 or 29 or both. I'll let you choose. And then do either 31 or 33. And do any of the odds 35 to 41. And try doing 43 or 45 or both. And we'll stop there and pick up the other. Now, dumb story. We don't have a lot of time, but I'll try to make it fast. Do any of you know who Beethoven was? I don't mean that big dog. Okay, that's something completely different. Beethoven, tell me. Composer, yes, a great composer. One of his symphonies, the Fifth Symphony, is one of the most famous in the world. Da 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 da. Yeah, it goes on. Beautiful piece of music, powerful piece of music, an incredible composer. To me, right up there. I love Mozart, but I mean Beethoven was right up there with him, and they lived fairly close to the same time. Well, it's a lot like today. Y'all probably watched the Grammys, or some of you did. Okay, you can probably tell me. Can you tell me who won the Grammy 5 years ago? Probably not. Okay, I wouldn't have a clue. Okay, and it was not quite that bad back then, but musical taste changed. Now, Beethoven was the greatest composer at his time, but a little bit later, people got tired of these big symphonies. They wanted something a little lighter, and they sort of forgot about Beethoven. Well, back then, there was no Social Security, and he had to support himself, and what he did was write music, and people weren't buying his music anymore. So basically, he wound up a pauper, destitute, even though he had been the greatest composer of his age. And also, just another fact, he went deaf. Now, if you can imagine a composer going deaf, that would be pretty tough, right? He was so incredible. What he did, he himself or somebody, cut the legs off of his piano, because he composed on the piano, sat it on the floor, and he sat on the floor, and he felt the vibrations, and he knew whether it sounded good or not. This guy was a genius. I mean, incredible. But I think he was a cranky old man, too. A lot of geniuses are, I think, weird kind of. And so when he died, I think the landlord or whatever just called for him to bring in a hearse, and he was buried in a pauper's grave. Well, sometime later, people said, I'm just sort of tired of this light and fluffy music. Where is that great stuff from Beethoven? Well, where's Beethoven anyway? Is he writing anymore? And then they found out he had died. And then they found out he had been buried in a pauper's grave, what do they call that? Potter's field, And so they said, no, we can't do this. We can't allow the greatest composer of all time to be buried in a potter's field. So they went through all the legal ramifications to go through the courts and stuff to get the body exhumed. They couldn't find any next of kin that I remember, so they finally got all the paperwork. So they went out and they dug the grave and were lifting the casket. And I think he was a pretty heavy old dude too. So it was kind of heavy, and this one guy, and the lid popped up. There sat Beethoven with scores of music in front of him, just racing like crazy. What was he doing? Decomposing, exactly. And I told you it was a dumb story, didn't I? Okay. Well, that's what we've been doing, decomposing, and we will do it next time. That's where we'll lead off to. Okay. Good deal. To sit through that, you almost should get extra points. But you won't. Okay. All right. Good deal. Yes, ma'am. Good deal. Thank you. All right. Still not going to mess with that one, huh? Okay. I'm sorry? Yeah, and if I'm not in the office yet, I'll be still up here, but I'll be on the way to the office. 265. If you go, you know where the orientation classroom is?
You know, straight in the hallway right there?
Yeah, right. They're down half a flight of stairs, almost to the end of the hallway, last office on the left, right before you get to the stairwell.
Okay,
Across the road, the hall from the orientation classroom. Right next to a family.
I'll go ahead and
Good
bring
deal,
my
thank
quiz tomorrow then.
Okay. That's
Right
perfectly
now,
fine.
I'll bring a lesson in there when I
Right.
take my friends out.
Right.
In the truck. And
Yeah.
Just work at 6 o'clock.
Right.
This morning, I forgot.
Right, no problem. Got it. No problem at all. All right, good deal. Now, if you're not through, you don't have to turn it in today.
Okay.
You still gonna work on it?
Yeah.
Okay.
Can you tell me what the library is?
Library? Okay. Let me sort of explain how to get there. Okay. Go out the door here and down this half flight of stairs here. Okay. Then go down one complete flight. And then when you go down